In this video, we will discuss inverse trig functions. I hope by the end of this video, you have a better understanding of what is arcsine, arctangent. So that's two major inverse trig function we will use. And yes, their domain and their graph. Okay, let's start from inverse sine function, right? So this is section 1.5. So this is about inverse trig function, trig functions. There are many, right? Inverse sine, inverse cosine, inverse tangent, inverse cotangent. But in our class, the two inverse trig functions are very important, are inverse sine and inverse tangent. Let's see what they are, right? Let's start from sine function. Y equal to sine of x, right? We know that the domain of such a function is all real numbers, negative infinity to positive infinity is also equal to r, right? We also know the range of such a function is from -1 to 1, right? Range is from -1 to 1 with the endpoint included, right? If you try to sketch a function, a graph of this function is a wave, right? And starting from 0, 0, go up and down and up, right? And same thing on left side. So we know that that's an odd function, so symmetric about the origin, right? So that's our y equal to sine of x. Now you can see that this function is not 1 to 1, right? Pick a 0, y equal to 0. There are many x, sine of x equal to 0. Sine of 0 equal to 0, sine of pi equal to 0, sine of 2 pi 0, negative pi, right? You name it. There are infinite many numbers in the domain are mapped to 0, right? But so this function in general has no inverse, right? So this function is not 1 to 1. In general, the inverse does not exist, right? So, but we don't want to stop here, right? We only look at a piece of this function from -pi/2 to pi/2. This green part, no, blue part. I can see that this is the function. The blue part is our function y equal to sine of x. Change your domain to be -pi/2 to pi/2. So that's a piece, a small piece of our sine function. The small piece is 1 to 1. This function is 1 to 1. This small piece for sure is 1 to 1. You can see that from picture. So the inverse exists, right? So if you have an inverse, you can calculate x equal, denote, right? X equal to arcsine of y and rewrite as y equal to arcsine of x, right? So the inverse of the blue part exists. So the inverse of y equal to sine of x on the interval from -pi/2 to pi/2 is, right? Let me, y equal to arc sine of x, right? You can see that the domain of arc sine, which is the range of the sine, right? They switch with domain to be -1 to 1, and range, which is from -pi/2 to pi/2, right? So that's the range and domain of this arc sine function. And you can sketch the graph of such a function, right? And just do a symmetric flip about y equal to x, because if xy is in the function sine, then yx is in the function of arcsine, right? Okay, so let's see the arctangent function, the second function. We will second trig inverse trig function we will use. Start from tangent function, right? So y equal to tangent of x equal to sine of x over cosine of x, right? You can sketch the graph of this function, right? This is a domain of this function is take a power 2, negative power 2, 3 power 2, right? And take away all the x, make cosine of x to be 0. So the graph of this function looks like this. So this is pi/2, 3 pi/2, -pi/2, and -3 pi/2, right? So you have some vertical asymptote, vertical asymptote, vertical asymptote, and the vertical asymptote, which means the graph of this function will getting closer and closer but never touch it, right? Closer and closer to the asymptote but never touch it. So that's one piece. There's another piece. There's a third piece here. So there are infinite many pieces of this function, right? Again, this function is not one-to-one, not hard to imagine, right? So why the inverse exists? We look at only a piece of this function, right? This is y equal to tangent of x on the interval from -pi/2 to pi/2. On this blue part, the function is one-to-one, which means inverse exists. So we denote the inverse by arctangent of x. So the inverse of y equal to tangent of x on the interval from -pi/2 to pi/2 is y equal to arc tangent of x, right? Domain is the range of that tangent. You can see that the range of tangent is from -infinity to infinity, with a domain of this inverse is for sure from -infinity to +infinity, right? Range is the domain of the original, which is from -pi/2 to pi/2. So if you try to sketch the graph of this function, you can sketch it. So this is pi/2, negative pi over 2, you have a horizontal asymptote in this case. So the graph of this function will be like this. On the right side of 0. And on the left side of 0 is symmetric, right? Symmetric about the origin. So this is y equal to arc tangent of x. Now you can see that as x getting larger and larger without upper bound, the function value goes to pi over 2, right? So as x goes to positive infinity, y goes to pi over 2. As x goes to negative infinity, let's replace y by our function name, right? Make it easier to follow. So we know that arc tangent of x goes to pi over 2. Arc tangent of x goes to negative pi over 2. Okay, so that's basically something we need to know about inverse trig functions, inverse tangent and inverse sine function, arcsine, arctangent function. And yeah, we should know their domain, this function, some like fundamental behavior of the graph, right?